Hi everyone, in this video we are going to discuss about numerical overcurrent relays. So before that, welcome to Triple E Department Lecture Videos YouTube channel. So numerical overcurrent relays can also call it as a numerical relays. These relays are latest development in power system production compared to the earlier type of relays. So earlier type of relays means like electromagnetic type relays, electromechanical type relays and static relays. So these relays are advanced relays. Compared to those relays, the cost of the equipment, the cost of the relay is more, and operating speed is more. Operating speed of the numerical relays are very fast than the electromechanical and electromagnetic and static relays. So these relays we can also call it as a advanced relays in power system production. So first we will see the what basis these relays will operate. So these relays latest development in the area of protection, that is called power system protection. So these relays are developed by VLSI. VLSI means very large scale integration and computer hardware technology. Computer hardware technology we can also call it embedded technology. Embedded technology means the combination of both software and hardware technologies. The combination of both hardware and software technologies. Next one is DAS. So these relays are operation based on the data acquisition system. So data acquisition system, why we are using is to compare, to analyze one relay with another relay, or one time to time analysis. So DAS is most useful. So data acquisition system. So when it is operated, when it is closed, when the relay is open, when the relay is closed, so those things easily we can analyze with the DAS, data acquisition system. So next one, this relays operation depends on processor and processing tools. So inside the relay we have a processor. So processor, if you are using, means we can use Zigbee technology, Wi-Fi technology, and IoT also. So we can operate these relays. So wherever you are, so we can operate this type of relays using the processor and processing tool. So processing tool includes Wi-Fi, Zigbee, and IoT. So IoT is nowadays most important, Internet of Things. So if you want to open the relay, so we can use IoT, and we can open the you can stop the supply also. So that is latest development in numerical overcurrent relays. Okay, now we will see the types of numerical relays. So these are classified into based on the technology. So what type of technology we are using inside the numerical relays. These relays are classified mainly 5 types. So based on the technology what we are using inside, that these numerical relays are classified. The first one, microprocessor based overcurrent relays. So here there is no hardware things, so only software things will be included in this type of relays. Microcontroller based. So microcontroller based, so which includes both software and hardware. So the main difference between microprocessor and microcontroller is, so microprocessor which has only software technology, microcontroller will have both software and hardware technologies. That is our difference. So microprocessor based overcurrent relays are only processor based, that is called the software based relays. Microcontroller based overcurrent relays are so both, which includes software and hardware. So the main difference is which microprocessor is which includes only software, microcontroller relays which includes both software and hardware. So next one, DSP, digital signal processing based overcurrent relays. So based on the DSP, so we are operating the overcurrent relays. So DSP, here we can use signal processing technologies. So what type of signals we are generating, how the relay is operating. So digital signal processing based overcurrent relays. Next one, field programmable gridded arrays, FPGA. So this is one of the latest development in numerical relays. Numerical. This type of technologies we are not using in static overcurrent relays and electromagnetic type relays. So field programmable gated arrays. So based on overcurrent relays. So field programmable means the program will be there. According to that program, these relays will operate. So here we have backup technology also. So backup technology means, suppose one relay is not operated, the neighbor relay will operate and isolate the faults. So that's what this FPGA technology is more popular in power system production. Next one, artificial neural networks, ANN. So artificial neural networks are based on numerical, so which includes both software and hardware, and so we can use IoT technology in artificial neural networks. So latest technology, AI, artificial intelligence. So artificial neural networks are old compared to AI. So these are the world nowadays. So the numerical relays are developing with AI technology, artificial intelligence technology. So those relays we still is not popular in power system production. So these are the five relays, or these are five different types of overcurrent numerical overcurrent relays are we are using in power system production operations. So artificial neural networks, ANN based numerical relays, FPGA based overcurrent relays, that is overcurrent numerical overcurrent relays, and DSP based, microcontroller based, microprocessor based. So these are the five overcurrent relays so we have in numerical overcurrent relays. So generally they will ask you to differentiate numerical overcurrent relays with static relays. So numerical relays are latest development in power system production. So these relays will operate with microprocessor, microcontroller, DSP, FPGA, and ANN based. And compared to while we are writing the differences, so we can explain about fast operation and maintenance. So these you can compare uh, we can compare advantages of static overcurrent relays with numerical overcurrent relays. So what we can compare is based on the operation, based on the maintenance, based on the cost, based on the size. So we can compare. So we now will see the what are the advantages than the numerical overcurrent relays with static overcurrent relays. So the size, if you take size, the first one, the size of the relay will be less. The size of the relay is numerical relay is compared to the static and electromagnetic type is very less. Next one, the cost is less. So maintenance also will be less. Next one, the space required for this numerical work and relays also will be less. So like this you can compare and you can explain differences between numerical overcurrent relays and static overcurrent relays if they ask in examination. Okay. So next we will see about distance protection. So this is one important part in your module 3, distance protection. So in this distance protection, so you have different topics, so different type of relays. So first we are going to study about introduction of distance protection, impedance relay, reactance relay, Moore relay, angle impedance relay. So these four types of relays very important. Impedance relay, so impedance we can mention with Z, reactance relay, so we can mention with X. More relay, more means admittance, so we can mention more symbol is Y. Angle impedance relay, so based on angle and based on impedance this relay will operate. Delta, angle is we are taking as a delta, impedance we are mentioning with Z. So these four relays are very important. And next one, effect of arc resistance and performance of distance relays. Each of distance relays, effect of power surges on performance of distance relays, effect of line length and source impedance on performance of distance relays. So these three effects, effect of arc resistance, effect of power surges and effect of line length and source impedance. So these three effects are majorly consideration in power system protection. So we will discuss about these effects in next further videos. Okay. So distance protection. So we'll see distance in detail in next video. Okay. Thank you everyone.